And there are others of you showing up, but we'll wait a minute or two because we have just a small crowd at this point. I guess I'm expecting a couple of latecomers, but I thought there would be more folks by now. Yeah, so I would expect you to give cogent arguments for your position and against theirs. Yeah. Good. Hey, Jackie. Grace, how are you? Greetings, everyone. Still don't quite have a quorum, so we'll wait another minute or two. See what we can see what are they the expression, see what the cat drags in or whatever. So did anyone get out and play in the snow? Build a snowman, go sledding, anything like that? No? I was speaking with one of my students. Some of you may know him, Clint. Yesterday, and as you know, he's from Hawaii, and so he said, before we talk about anything having to do with linguistics, I just want to let you know, I think snow sucks. So that must be a really rude awakening to come from a paradise like Hawaii and have to deal with snow. But yeah, but we don't have to deal with volcanoes here, I guess, in Ohio. So there's some trade-off, some benefit, I suppose. Okay, well, we're getting closer to a critical mass, so I will go ahead and get started. So I've managed to have a look at many of the papers that you turned in, and we will spend some time on that, so that by the end of the day today, you will be, or the end of the class today, you'll be in a position to attack the second part of this GBE reconstruction assignment. But let me first start with this. I'm going to put in the chat the hang on a sec, let me find it. Yeah, this is the and I can share my screen as well, so you can all see what I've yeah, there we go. Get this out of the way. You don't need to be reading my highly sensitive email. Not really sensitive at all. Okay, so this is the. I haven't heard from all of you. I was hoping to, but if you haven't signed up for a time, please tell me, because these meetings are starting tomorrow. But this is the. You can see the list, and those of you who let me know you're on the list at the appointed time. So simply check into to my personal Zoom room at the time that you signed up for, that I give you here. Many of you gave a number of possible times, and I just sort of made sure that there were no conflicts. So I have the waiting room function activated for my personal Zoom room. So when you show up, you won't be let in immediately, but you will be put in the waiting room, and I will finish up, particularly when they're sort of back to back or back to back to back like they are here. You'll just have to just wait a minute or two, and I'll once I know you're there, I'll finish up and move on to you. Okay. So if you haven't let me know, please let me know by the end of class today, so we can find a time to meet. Okay. And as you may have seen, I'm treating this as a homework assignment. If you meet with me, you get a 10. If you don't meet with me, you get a 0. It's that simple. It was just a, you know, I have relatively few weapons, so to speak, at my disposal to get you to do things, and a grade, turning this into a graded assignment was the blunt instrument that I just about the only blunt instrument that I had at my disposal to use to get you to meet. So we'll have 15 minutes of discussion. It can be about the class. It can be about anything in general. It's really just a matter of checking in and seeing what's doing with you in your semester in general, and in particular in the class. Okay, so I look forward to the opportunity to get to know all of you better in this way. Okay, so this I want to get rid of. We'll start to, I guess I want to get rid of, no, I want to keep this one up. I want to start today with my t-shirt du jour, my daily t-shirt du jour. You use something that's redundant. And this, as you can maybe see, is a t-shirt that is about something very important that we mentioned last time, and we will talk about today, and we'll talk about next time. And that's Occam's razor. And this is what the t-shirt looks like, in case you're wondering, in case you can't quite see it clearly enough there. It says, trust Occam's razor. We will learn to trust Occam's razor. Occam himself, William of Occam, was a medieval philosopher, as I think I mentioned. I can show you a picture of him here on his Wikipedia page. He's famous enough to have his own Wikipedia page. There he is, William of Occam, 13th, 14th century English Franciscan friar, scholastic philosopher and such. And he is known for this, as they say here, this methodological principle that bears his name, Occam's razor. He did not refer to it as a razor. In fact, the way in which it is usually cited in the literature, I didn't give you this the other day, but I will give it to you now, is that is this entia non multiplicanda sunt praeter necessitatem. Entities, entia, are not multiplicanda. This is in Latin, by the way, are not to be multiplied. And the important thing here is praeter necessitatum, without necessity. And that's really what gives us this this parsimony type argument, that you don't make, the way I put it the other day was, you don't make things more complicated than they need to be. Instead, you aim for a solution that satisfies all of the facts that need to be accounted for, that accounts for all the facts that need to be accounted for, and doesn't multiply entities needlessly without necessity. It's not the case. We'll see. I'll show you something about this next time. It's not the case that the simplest solution is right. That's not the statement of Occam's razor. It's really, if you have two solutions that do the same work, the one that posits fewer entities, requires fewer constructs, less stuff that you have to put into it, that's the one that is to be preferred. That's really what Occam is about. So in a sense, it's about not the best solution, but the better solution, the better of two. So, and this is really what, the reason it's important as a scientific principle is that it gives you a way of deciding in a principled manner between two alternative hypotheses. And that's what the scientific method is really all about: propose hypotheses and evaluate them in some ways. So we'll, yeah, so this is, this is the schema that we keep coming back to for good reason. But what this sort of schema allows you to do is to generate hypotheses. In this particular case, we're generating hypotheses about elements in the proto-language. the evidence that we're basing those hypotheses on is the evidence of the features in languages that we're comparing. That's the horizontal comparison that I've been talking about. And then we evaluate the hypothesis. As I say, we're not looking for what's best, we're looking for what is better between two competing hypotheses. And then what we do is if necessary, and this is where it really becomes a matter of of applying the scientific method, is we go back and revise hypotheses as needed. So we evaluate the hypotheses and we say, okay, this one works, so I'm going to stick with it, or neither of them work particularly well, even if one is better than the other. So we go back and revise the hypotheses. Is there a yet better hypothesis that we can put forward? And that's really the essence of the scientific method. And we like to talk about linguistics as the scientific study of language. So adhering to a scientific methodology is really important. And Occam, for all the fact that he didn't exactly say, I didn't mention that, but this is the way the Occam's razor statement is usually cited in Latin. But if you go through all of Occam's works, I haven't done that, but scholars who I trust have done so. He actually never says it in these words. Yet this is the common formulation that you'll find for Occam's razor. That's why the date on my T-shirt, you can see, is since 1852. That's when this particular statement of Occam's razor became sort of widely popularized. So Occam himself was from the 13th, 14th century, but this particular statement and the claim and the label that this is Occam's razor dates from the 19th century. Can anyone see the metaphor involved in calling this a razor? Anyone want to talk about that, address that?
I always had some mental image of shaving away that which is unnecessary.
Yeah,
something.
Yeah, exactly. I think that's what's involved. You sort of pare things down to their essence, as it were, and so it's like a razor, like a straight razor in that regard. Yeah, good. Okay, so that's the T-shirt du jour, and that gets us going on an important topic. And what I want to do today is to make it clear why it's an important topic. It's not just for sort of philosophy of science kinds of reasons and trying to talk about linguistics as a scientific enterprise, but it has some very practical applications to the exercises that we're working on. And they aren't just exercises to keep you busy, but this is one type of work that historical linguistics involves. It's not the only thing. We'll see lots of other ways in which we can deal with language change, but one particular aspect of what we do in historical linguistics is to try to reconstruct and then determine details about language history. The history, by which I mean the history of particular languages, but also the history of language more generally, what happens when languages pass through time. That all emerges out of this reconstructive exercise. And I see we have a question in chat. Okay, Kyle, you come and go. That's fine. Thank you for letting me know. As a couple of you know from my other class on Monday and Wednesday, my connection just died out of nowhere in the middle of class in the afternoon, my afternoon class on Monday. So I'm sensitive to the fact that unstable internet connections as a plague all of us at various times. Okay.
And Professor.
Yes.
Do you? It's he recording. Yes.
Yes, I am.
Sorry.
Yeah, I'm ahead of you on this one. You see, I've got my, not only do I have my T-shirt, but I have my message to myself.
Okay, great.
This time I believed it, but thank you. No, I appreciate your all, any one of you checking on me like that, because I think it's all too easy to forget about that. I get caught up in the excitement of the class starting and forget about that key element. So if the if what we're doing here is generating hypotheses, in this case, hypotheses about the elements in the proto-language, the evidence that we're generating those hypotheses on is the way the proto-language elements developed into the elements in the languages we're comparing. That's what this F1 and F1 prime and F1 double prime are supposed to indicate. These are the, does anyone recall the technical term that we used for the outcome of the way the proto-language elements developed into the languages we're comparing? There was a term that I used the other day that I think is, anyone remember it? No? Starts with an R. Does that help?
It reflexes.
Reflex, exactly. Yeah. So these elements the ways in which the proto-language elements are realized or reflected in the individual languages we refer to as reflexes, the reflexes of the proto-language segment. And to a certain extent, the can't remember if let me see. Anyway, to a certain extent, the proto-language elements are defined by the reflexes in the proto-language. So when we have, for instance, in the Gabay case, I think I already wrote this in. Yeah. So in the Gabay case, when we have these reflexes, this is for numbers items 1 through 5. We find this set of reflexes. This really is defining a proto-language segment of some sort, whatever it may be. You know, that's a different kind of decision. But the point is that this element is defined by these outcomes and this particular collection of outcomes. And though it isn't relevant here because the outcomes are all the same, the reflexes are all the same. Remember that we did say it's not just the set of outcomes, the set of the reflexes, but the order, their order as well. Where order, what is order equivalent to in say in something like this? Why would this set be different from one that was, say, that had the S's in a different place, like that? Same number of T's and S's, but in a different order. What is the order referring to here? Why do we talk about the correspondence set as an ordered set? Anyone recall?
Each position corresponds to a specific language.
Yeah, right. Each position corresponds to a language. If we got fancy and labeled this as, you know, I can't remember the exact order, but Alada and then you know, fawn and so forth. If we did it that way, then we're effectively giving an ordering to the set. If we just sort of lay them out in a string-like form like this, then the order matters, and we would want to we'd want to be sure that our that we say, okay, this one and this one are not the same. And they have the same elements, they have the same number of elements, but they're distributed across the languages in a different way. And that's what we mean by talking about this as an ordered set. So the order here is the distribution of the reflexes on a language by language basis. But their order matters too. Okay. Okay, that's just an aside, but an important one. Okay, so what we what's really at issue then, if we say that what we're doing is generating hypotheses and then evaluating them, what we need to figure out is how do we evaluate? What is the basis for our evaluation? If we say we're trying to determine, given two possibilities, which is the better solution, how do we know which one is better? That's really what the evaluation process, the evaluation step is all about. And this is where our scientific principles come into play. And I didn't, you know, I didn't want to come across as being sort of heavy-handed the other day when I said that we will, the sort of common sense notion that many of you brought to bear on your assignments of majority rule, which, as I said, sort of works for politics and other kinds of arenas. It's, as I say, it's kind of a common sense notion, but it's not scientific. And what we want, if we really wanted to say that what we're doing and what we're engaged in is a scientific principle or a scientific enterprise, we don't want it to be just to boil down to a numbers game. What do the numbers mean? What they mean is that certain analyses require more apparatus. Certain analyses oblige you to posit additional material that isn't needed in another analysis. That's when you are really invoking not majority rule, but rather invoking the scientific principle of the law of parsimony, which we talk about popular or in our informally, I should say, as Occam's razor. So that was why I sort of in my heavy-handed way said, no, we won't use the term majority rule. It's common sense, maybe, but it's not a scientific principle in itself. We can recast it into the scientific principle of the law of parsimony or Occam's razor, but it's not in itself a scientific principle. What we do want to do first of all is to, in terms of evaluating, we want to make sure that we account for the facts at issue. That's really a matter of what is sometimes referred to in the literature as descriptive adequacy. We want our accounts to be descriptively adequate. They have to account for the facts at hand. If you're in the case of our, you know, in the case of our Gabe case of our Gabe languages, whatever we come up with has to account for the fact that you have a T in initial position in these languages in words that match up in a certain way. So descriptive adequacy is sort of absolutely essential, and that's what leads us to what I said here. This crucial piece of understanding the application of Occam's razor is all things being equal. All things being equal really amounts to descriptive adequacy. Now, this might sound like a lot of, you know, sort of airy philosophizing, but it isn't. I'm trying to get you to understand the foundational elements that our reasoning is based on, and that's really the reason that, or the method behind my madness here in going through some of these seemingly philosophical notions. I want you to understand why we do what we do. Not just, I don't want you to just apply particular, you know, recipes or cookie cutter type methods. I want you to understand the underlying principles that go into it, that shape it. So, so first of all, we aim for descriptive adequacy. If we have two accounts that are descriptively adequate and that they give you a way of evaluating, of accounting for the facts at hand, then that's what we mean by saying all things are equal. And it's at that point that we can then say, well, it isn't a matter of your analysis doesn't account for the facts at all. It just doesn't do so in a way that is parsimonious. That's where Occam's razor comes in. So that's one scientific principle that we can invoke in order to develop a particular solution or a particular account. So in a case like this with the t, we can entertain a couple of possibilities. I think everyone said, why don't we reconstruct t here? But we can compare that with a reconstruction, say, theta. Both are descriptively adequate in that t says, oh, I'm sorry. What am I doing wrong? Yeah, there we go. Plus no real changes, right? Versus, so that's one account. Let me make this a little smaller so we can fit it all on one line, okay? Versus reconstruction theta. What does theta, reconstruction of theta need to be descriptively adequate? How do we get from our proto language with theta to our attested language? How do we make it descriptively adequate? A descriptively adequate solution starting with theta. Anyone? Well, let's go back. I hate to keep doing this, but let's go back to our starting point here. If our starting point is theta, and we're trying to get to t here, and t here, how do we do that? So in this particular solution, we have theta, t, and t that we're trying to get to. What do we need? What do we need to make this a descriptively adequate statement? It's descriptively adequate account. In the case of t, that was all we needed to say because there were no real changes at all that needed to be posited. But what do we need in this case to make it descriptively adequate, to account for the facts of t in each of these languages?
Every language would need theta going to t.
Right, yeah, so we need a change of theta to t, and not just in one languages, but in, not one of the languages, but in 5 languages. So now we have two accounts. We can call this one account A, let's say, and this is account B. We have 2 accounts that are descriptively adequate. Do you all see why they're descriptively adequate? They both account for the facts. That's what we mean by saying they're descriptively adequate. But are they equally parsimonious? We take the next step. Can we, now that we have these 2, all things are equal in terms of descriptive adequacy, how do we actually evaluate them? One of the ways would be invoking Occam's razor. And is there a difference between the 2? Obviously, yes, but please, someone tell me. I want you to be, sometimes it's really good to be explicit about your reasoning, even if you say, oh yeah, I sort of, yeah, right, I understand that. It's good to be explicit. So would someone be explicit and tell me how do you apply Occam's razor to solution A versus solution B? How do you apply the rule of parsimony? No one want to take a stab at it?
I'll try. I think
Who's that?
this is Kenna.
Kenna, go for it.
A has less entities, right?
Yeah, right, yeah. And put it the other way around. What entities does B have that A does not need?
The theta to t in 5 languages.
Right, yeah. So this is the sort of extra entity not needed in solution A. And it's not only not needed once, but it's 5 times. You have to invoke it 5 times in B to get things to work. A, it's not there at all. So there's a real, thank you, Kenna, that was exactly the answer I was looking for. The extra entity that's posited in B, that is not needed in A. So that means that this is something that has been added praeter necessitatem, without necessity. Because you can get away, you can come up with a descriptively adequate solution, namely reconstructing T, that doesn't have this added entity, this added construct that needs to be posited. So that's the extra entity. The entities have been multiplied beyond necessity. Okay, I don't mean to belabor this, but I do want to kind of hammer it home, because this is a really key concept. So for that reason, we can eliminate B. We have now evaluated, we have 2 hypotheses, they account for the facts equally, but they differ in terms of parsimony, and therefore we have reason to adopt solution A rather than, and we can eliminate B. Any questions about this? If this doesn't make sense, please ask a question about it, because it's really important that that you understand the basis for the reasoning here. I don't see any hands up. I don't see those of you who are showing your faces. I don't see any puzzled looks. So I'm going to assume that this very painstaking explication that we just did makes sense to you. Going once, going twice. Okay, sold. On to the next one. So what about this, the set involving S's? This is in numbers 6 through 9. Would someone like to kind of talk through the how you deal with numbers 6 through 9 in exactly the same way that we did with numbers 1 through 5? Someone feel bold enough to do that? No? What would be 2 conceivable hypotheses here that would and how would they account for the facts? What would be our solution A here? Versus our solution B. Anyone?
S.
I'm sorry, Ginny?
Yeah, the S.
Okay, so let's say that A, we reconstruct an S, and then what do we need to do to make it descriptively adequate to make sure that we get the outcome that we want? Do we need to add anything more to it?
No, we would just say no change in languages.
No changes. So there's an important assumption here that we assume in this kind of schema that unless you say something overtly about a change, the default is for things to remain the same. So stability is the default in this sort of modeling that we're doing here. Stability is the default. If something changes, you need to expressly say that. Now that's kind of at odds with the with the fact that we say, well, change in language is pervasive. You look at any 2 stages of the same language and you see all kinds of differences and so forth. So that makes it look like change is normal, and in a certain sense it is. But in the way we model it here, we are taking the view that unless you overtly change something, it's going to stay the same. So stability is is the default situation, and change therefore needs to be overtly taken note of in some way. And that's really that's maybe why I think I mentioned this a couple of times, that we pay so much attention in our historical linguistics classes to changes that we sometimes lose sight of the fact that there's probably greater stability between stages than there is change. But we pay attention to the change because we expect things will stay the same unless they are changed. And that's why I've used the term, I guess I'll put it here, innovation instead of change sometimes. And innovation is really a deviation from the status quo, from the way things are. Anything that moves away from some existing state is an innovation, viewed in these terms. Okay. Put that in parentheses here. So here we are with S. And if with our solution A, we reconstruct S, no other change is needed because of our assumption about things remaining the same unless we say something. What would be, what would be a candidate for the bad guy, the one that we're going to strike down here? You see where this is going, of course, but what would be a possibility here for B? Anyone? It does,
Maybe an esh.
Esh, okay. Fair enough. And I can type an esh reasonably well. And what do you then have to posit? Who is that? Who is that?
That was me, Oscar.
Oscar. Okay, go for it. So what would you? What? This is not descriptively adequate, according to our assumptions about things remaining the same unless we overtly take note of the change, of the innovation. So what more do we need then?
You would have to posit that in 5 languages you have esh going to s.
Right. Oops. And then how would you then, now at this point, now they're descriptively adequate, right? They account for the facts that we need to account for. You all see that? Yeah. Okay. So what then is we can then move on to the next step of evaluating. How do we evaluate A versus B? How do we do that? We already did it in the case of the first set of corresponding elements. But I'd just like to hear someone say it overtly. As I say, it's sometimes good to be explicit, to formulate exactly how you're going to phrase things. It can help you sort of sharpen your understanding. Anyone want to take a stab at that? No? No one, no daring souls out there who want to give it a go?
I mean, I could just redux what I said for the previous one, right?
Okay, yeah, why not? Why not? You're on a roll, go for it.
Because you have 5 more extra entities for B because you have to do esh to S 5 times.
Right. B requires esh to S and requires it 5 times. So I mean, you could think of it as 2 different ways in which it's less parsimonious. You can think of it as 5 ways in which it's less parsimonious. The point is it's less parsimonious and requires this in 5 languages. Therefore, we can, based on Occam's razor, we can say, sorry, Charlie, you're out of luck. Okay. So now we're making some progress. We have a good solid basis for our reconstruction of T for 1 through 5 and S for the 6 through 9. Okay. Now this is the easiest case, and this is maybe even easier than the Burmese Berman problem that you did, because if I told you just to do 1 through 5 and 6 through 9, it would have been a piece of cake. Everyone would have done beautifully on it. Things get more interesting and more complicated, and that's why I wanted this to sort of unfold it in this order. When we look at numbers 18 through 22, and it gets even more complicated when we look at 10 through 17. That's what you're doing for next time, but as number 6. But this is this is a way of by doing these 3 parts in this order, it's a way of sort of getting to a point where you can confront some of the complications, but at the same time, as I said the other day, you'll have a foundation for looking at the remaining data in 10 through 17. So what is the complication that these pose? This particular distribution of reflexes that we find in 18 through 22. Can someone put it in words for us? What makes these interesting? What makes them, from my point of view, pedagogically interesting? From your point of view as trying to deal with language, what makes it an interesting puzzle to try to work out?
It's not uniform.
Okay, it's not uniform. So in terms of so that's going to pose a sort of an analytic decision about what to, thus an analytic let's say dilemma as to what to reconstruct. It's perfect. It's so straightforward in 1 through 5 and 6 through 9, and then all of a sudden you get here and say, wait a minute, it's not as straightforward as that. So there's a dilemma of a certain sort. But the dilemma is even more interesting than that, because what are the, if you're just applying now sort of a common sense view of what to do with these reflexes, what would 2 leading possibilities be to get you to outcomes that look like this? Let's say leading candidates.
You could try T or S.
All right, okay, so getting the outcomes or reflexes in 18 through 22, T or S. And what is the dilemma that those pose? Anyone?
This reflex is an overlapping distribution with the previous 2 reflexes.
Yeah, so so you've already used T and S. So if you want to, and I say used because for 1 through 5 and 6 through 9. So how can we reuse T or S for 18 through 22? That's the dilemma. Or that's it. So we have 2 dilemmas. First of all, what do we reconstruct? It's not an obvious choice. That's dilemma number 1. And then dilemma number 2 is, well, the obvious choices. The obvious choices are ones that we have already used in our reconstructions. Now we need to ask first, why is reuse a dilemma, a problem, potentially? Anyone? What is potentially problematic about saying that that we reconstruct T for 18 through 22, or S for 18 through 22. What's problematic about that?
Well, we need to make sure that whatever changes we might propose to explain how we got from T or S to the reflexes we have don't apply in other areas where it'll give us the wrong result.
Okay, good. So, so would changes needed for T or S here conflict in some way with developments we have already posited? Do you all see why that's a potential problem? So we said up above here that where was it? The T simply stays as a T, and down here we're saying, well, wait a minute. In two of the languages, we'd have to say that T turns into S. How can we get that to work in the last two languages? I forget what the last two. I've done this so many times, and yet I don't remember the order of the elements. Anyway, I'll just say the last two languages. So this conflicts versus T staying as T in 1 through 5. The same kind of problem would be if we reconstructed S. And how would you state the conflict there? Anyone? What would the conflict be in if we reconstruct an S? Because we want to get for it to be descriptively adequate, we want it to get to look like this. So what would we have to say if we start with an S as our reconstruction? What would we have to say to get these outcomes, and therefore for our account to be descriptively adequate?
Would it be S to T in the first three languages?
Yeah, right. Thank you, Kenna. S to T in versus S remaining as S in 6 through 9, right? So there's a conflict there. And the the way in which we resolve this conflict really depends on a couple of methodological steps that we need to be very clear about, and which we can apply. I hope you had the chance to read the account that I posted about the steps in the comparative method. But this is where, based on the Polynesian case, we'll go back to that once we finish with this. But I wanted to get this set so you're in a position to work on the remaining Gabay data over in between now and next week. This is where we have to begin to pay attention to the environments for the reflexes and for the correspondence set. And this is the sort of key methodological step at this point. And why is this important? Paying attention to the environments. Why do we take this step? Would there be a way in principle of saying, well, T it stays as T in 1 through 5, but it turns into S in 18 through 22. How could T become T in 1 through 5, but become S in 18 through 22 in those two languages that show the change? That's really what the question is. Is there a way of resolving that? Or how can we, how can we decide? And how does attention to the environments potentially matter for answering this question?
When you write the rule, after you say like T goes to T or T goes to S, you specify the environment, which
Okay.
in the case of like this language is a vowel in both of them. So like whatever type of vowel you can specify as part of the rule.
Okay, so T becomes T before a vowel, and in numbers 1 through 5. Thank you, Claire. And or else it becomes you say also before a vowel. And why is that in 18 to 22? And why is that a problem? There was a principle that we mentioned the other day, sort of towards the end of class. It was our second scientific principle, one that is not general for science, but rather specific to the science of linguistics, and especially the science of sound change. Anyone recall what I was talking about? Remember that silly joke I told you of my father's about the kiddly beans? What was the point of that? Don't
The
make
regularity of sound change.
Exactly. I was going to say, don't make me tell the joke again, but yes, regularity of sound change. And what did we mean by regularity of sound change?
We will expect the same change in the same phonetic environment.
Right, exactly. We expect the same change in the same, our expectation, we expect that the same sound in the same environment will behave in the same way every time we see it. That's really what regularity of sound change boils down to. We will be a little bit more specific and a little bit more sort of formal in how we define regularity of sound change. But it's based on the expectation that sounds, the same sound in the same environment will behave in the same way, regardless of what word it's in, or whether it's a grammatical word, a grammatical suffix, or whether it's a content word or whatever. It will behave the same based on the environment. And therefore, in just this sort of rough and ready formulation here, say, well, T stays as T before a vowel, and T turns into S before a vowel in 18 through 22. That's a problem, potential problem. Now we can get around that by saying, well, maybe the kind of vowel that's involved matters. That would still, if we, and this is something where you can only really get at it by having a what do I want to say, developing your experience more with these kinds of exercises, and that is how much detail do you put into your environment. Vowel, I mean, there are lots of ways in which vowels can differ from one another. So we might want to say, okay, yes, it looks like we have the distribution here that overlaps. In that both occur before vowel, but maybe we have to wonder, does the type of vowel matter? So we might have to be we might have to be more specific about the nature of the vowels involved, just to be absolutely sure that that we're talking about overlapping distribution. And let's look at the Gabay exercise for just a moment then. Now, there's a mass of data here, but what we're interested in is 1 through 5 and 18 through 22. This is where you start, you have to sort of look at these items, look at these, at the data on a sort of an item by item basis. And you say, so what is the, what, are we dealing with the same vowels in each case? In 1 through 5. There's an easy, simple answer here, but I just want someone to say it. Is the same vowel involved in all of 1 through 5?
Nope.
Nope. Thank you. Thank you. And why not? They differ in a couple of ways, actually, right? They differ in terms of what's the difference between the O and E, for instance, here in these, which is a difference that's more or less repeated across all of the languages.
Fronting.
I'm sorry?
Well, the O is like a back rounded vowel, and the E is a front unrounded vowel.
Right. So they differ in terms of their quality, and the features that make up that vowel quality, front versus back, round versus unround. Those are things that we might, in principle, want to pay attention to. So as we work on the does the type of vowel matter? For instance, vowel quality, front, back, round, unround. What other features go into making up a vowel quality? What's the difference between E and ah, for instance?
Vowel height.
Oh, vowel height. Okay, so high versus low. And there might be others as well, but those are sort of the key ones that we look at. What else is different about the vowels here? What's the difference between? It looks like in 1 and 2 we're dealing with the same vowel, the open O, but they aren't really the same here. And why? What's different about them?
One has a high tone and the other has a mid tone.
Right. So they differ in terms of their tone, and and in this case, the tone is marked because it's something that ultimately you want to pay attention to. So there can be other things as well, like tone or maybe stress, which is not marked here, but there could be other kinds of sort of overlay functions, nasality, versus non-nasal. We might say that's a type of quality, fair enough. But these are all ways in which vowels can differ from one another. So in principle, we say, we might want to, just to be absolutely sure, say, what am I looking for here? Just to be absolutely sure, we might want to say, we really should look at the properties, the features that make up these vowels to see, is it really the case that these overlap? And there's actually, it turns out that there's one very easy comparison that you can make between 1 through 5 and 18 through 22 that sort of instantly seals the deal, instantly tells you that they're overlapping. Does anyone see what I'm referring to here?
You could look at 3 and 18, for example.
So 3 and 18. What about 3 and 18 that's significant? Who is that who was telling me? Is that Oscar?
That was me, Oscar, again.
Yeah, sure. So what is it about 3 and 18 that's significant here?
The environments are exactly the same.
Exactly the same. We have a high-toned O in 3 all the way across the board, so there's really no question as to what to reconstruct. There's a high toned O in 18, so therefore no question at all about what to reconstruct. So if you get down to the, in this case, if we get down to the details of vowel quality and tone, we find number 3 and number 18 totally overlap completely. It's not there's no wiggle room whatsoever at all there. It's the exact same environment. That is to say, this high toned O, like that. Are there any other words that are like that in the data in question? Between 1 and 5 and 18 and 22? Anyone see any others that are where you have the identical vowels? There's another one lurking there, I promise you. Anyone see it? It's right in front of your eyes. Is it this one, number 1? Number 2? Is it door number 3? Well, 3 we were already taken care of. 4 and 5. Do any of these vowel patterns recur in 18 through 22?
2 and 19.
Yeah, look at number 2 here. Oops. Look at number 2 here. We have the open O, high-toned open O in all of the languages. And 19, high-toned open O. So I can't write the symbol for an open O easily, but we can say also high-toned open O. The exact same environment. So what does that tell us then about the, can we reconstruct T for 1 through 5 and for 18 to 22? Yes or no? How many of you would vote yes? You're able to vote, right, with your reactions. How many of you would vote yes? Let me see a thumbs up or a yes or something. I see Kenneth says yes. Jackie says no. We're going to go by majority rule here. Let's see who's going to break the tie. Rebecca says no. Everyone else is abstaining. Okay, looks like the no's have it. And more to the point, why? So if we say no, why do we say no here? What principle really not only allows us, but really demands that we say no in this case? What principle? Regularity of sound change, right? How is regularity of sound change? How would it be violated by reconstructing T for both of these? Anyone want to put that in words? How would regularity be violated? Or expectation that the same sound in the same environment will behave the same way. What would be problematic with this?
Sometimes a change from T to S and sometimes change in what we think is the same environment.
Yeah, right. So what we have here is in the exact same environment, the same sound is behaving differently. Sometimes ending up as T, sometimes ending up as S. And therefore, if we adhere to regularity of sound change, and we're just at the very beginning, so at the moment we'll say, yes, let's adhere to this as a principle. And I told you, with that silly joke that I gave you and dialect dialect shibboleths like Pak, Yurkan, Haberjad. I gave you a basis for why we think that it might be plausible to think in terms of regularity of sound change. So if we keep that as a principle, then we, or if we use that as a principle that guides our evaluations, it tells us that we can't reconstruct T for these two different sets, correspondence sets. Does everyone understand that this is a very crucial application of a principle? We will ultimately, maybe not today, but certainly next Monday we will we will develop the sort of underlying principles that lead us to think in terms of regularity of sound change. For the moment, it's based on our sort of common sense idea that the same sound in the same environment will behave in the same way. But is everyone clear about that? If you're not, please ask, because this is important stuff for historical linguistics. I think important in general, but certainly for the kind of enterprise that we're involved in here. Okay, it looks like everyone's okay with this. What about reconstructing S here? This is our other possibility that we were entertaining. Can we? Does that have a hope of surviving? What did we use the S for in our data in our first pass through the data? What did we reconstruct S for? It was for these, right? 6 through 9. So is there any, instead of simply saying, well, it looks like you get S before a vowel in 6 through 9, and you get S turning into T in 18 through 22 in these examples here. Do we need to, if we decide to, maybe vowel is a bit too coarse in terms of the granularity of the environment, can we look at it in terms of vowel quality, the tone and so forth? Do we have the same kind of situation that we had with 2 versus 19 or 3 versus 18? Are there any instances in 6 through 9 that are exactly the same environment as we see in 18 through 22?
Seven and 19.
7 and 19. So 7 has a high-toned open O, and 19 has a high-toned open O across all the languages. So there's no real doubt as to what we would reconstruct here. And so can we reconstruct S then for for 6 through 9 and 18 through 22? What's the answer? Let's see if let's put it to a vote, and let's see if more of you are willing to vote now. Oscar says no. Ginny says no. Rebecca says no. Kenna, no, no. Oh, looks like it's no's everywhere. That's great. Okay. Anyone want to say yes? Anyone want to? Nope. Okay, good. So the no's have it. The answer is no, because of two things. Because of the high-toned open O environment, and what's the other thing? Two things that are involved here that tell us we can't reconstruct S. The high-toned open O, and what else? This is a bit of a trick question. Regularity of sound change. So the environment coupled with the principle that we're adhering to for now of regularity of sound change tells us that we can't reconstruct S for both 6 through 9 and 18 through 22. We have to come up with something different. And that's where the fun begins. So 18 through 22, not T and not or nor S. So what? And that's where the fun begins. A few of you had some suggestions. I think, unfortunately, I think most of you got sort of trapped in trying to somehow shoehorn this set into T or S. And some of you did so without looking at the environment carefully. Some of you did so without thinking about regularity of sound change. And that's okay. Because the reason we do these exercises is so that you learn from them. If you knew everything that you needed to know at this point, you wouldn't have to be in this class. But you're in the class, so we're trying to develop our methodology, develop our understanding of what's going on here. So looking at the environments here and keeping regularity of sound change in mind tell us that whatever we reconstruct for 18 through 22, whatever we reconstruct, it can't be T and it can't be S, unless we want to go back and change our reconstruction for 1 through 5 or 6 through 9. We could do that. And I mentioned, way back here, I said as part of the scientific method, what we do is we can revise hypotheses as needed. So we could go back and revise the hypothesis about T in 1 through 5. Can anyone give me a reason why that would not be all that advisable a step? Here we were. We decided to reconstruct.
We've already discussed that it wouldn't be parsimonious to reconstruct any other sound.
Okay, Oscar, you can carry on. Oh.
I wanted to tell him when I saw it was at 8%, and then I forgot.
Yeah, I noticed too. I felt like I should have unmuted, but I didn't know if he was like, yeah, I know. It'll probably last. Or something like that.
Listen. Okay. I don't think so. Maybe he won't because I'm in Brazil. Last time he didn't. No, okay. He said, my computer just crashed. I will try to log on. Please tell Fox to wait. Yeah, he just sent a message. And everyone got the Hooks book? Because I found one PDF, and then if anyone wants, I can send it to you. Okay.
I would
Awesome.
like that.
Yeah, I'll take
You
that.
do.
I haven't bought it yet, to be honest.
Okay. Yeah, it's too expensive, especially
I
for me
know.
because I'm here in Brazil and everything I try to buy from there, it's horrible. But I can upload it and I think there is some part on Carmen,
Okay.
right? For where we can find all of us in this class. Or you can send me an email. I'm gonna write my email here and then I can, I don't know if by email it's possible to upload, I don't know. But let me check my email here at Ozu. I will see.
You could also upload a file to the chat of this class. Okay.
Here, do you think so? Let me see if I can. It's uploading.
Hello, can you all hear me?
Yeah, you all can
Yeah.
see it now.
Okay, you can't
Yeah.
see me because I'm phoning in, but yeah. So something happened. My computer crashed. It's restarting now. It won't restart in time, I think, to be able to do anything with the last couple of minutes. But I think I got the basic points across that I was hoping to, and I hope that you're in a position now to work on the rest of the Gabay problem for homework number 6. If you haven't already, please do have a look at that sheet that I gave you on the steps in the comparative method based on the Polynesian case. I'd hope to get to that today, but obviously we're not going to. But I think that gives you a fairly clear walk through the Polynesian example. And other than that, have a good weekend. I hope my computer will survive till next time, but we will meet again then on Monday. Okay, take care, everyone. Thank you.
Okay, bye-bye.
Thank you.
Bye.
And thanks, Marcia, for the PDF. You're my hero.
Oh, good. I always like to hear that.
Okay.
Oh, okay, there. I will.
This is proof of concept that it's possible for me to connect with you by phone and to connect with you, reconnect with you. I'm glad that worked. Okay, good. Sorry about that. I guess the recording, I can stop that now. Good. So